Okay, today's ellipses. Definition, the set of all points. Set of all points whose distances from two foci sum. Sum to a constant. What does that mean? What does that mean? How many foci did you have in a parabola? One. How many do you think you have in a circle? You have one. And it is simply the center. Okay? It's that center would be the focus, and you simply just extend a radius all the way around it. What happens with an ellipse is it has two. And if I simply took like a shoestring and tied it so it made a loop and put two fingers inside of that loop, you could then try to extend that loop all the way around the marker, and you would draw an ellipse. You would, instead of traveling around one point, which would make a circle, you'd travel around 2 points and make an ellipse. And we can do that demonstration tomorrow, but just to help you understand again what this is, if you draw an ellipse at the bottom of your page, what happens is these foci, they sit kind of near the end of where it's stretched. And if you were to pick any point on that ellipse and look at the distance, those two distances would sum to the exact same number that the blue segments would sum to. They would add up to the same amount. That's the definition, okay? Are you going to have to reduplicate it? No. And do we actually make those in order to draw it? No. Ellipses are by far the easiest shape to draw when it comes to conic sections. Sure. So the equation for an ellipse looks like this. X squared over a squared plus y squared over b squared is equal to 1. And what happens is if whatever number is under x squared, we take the square root of it. What's the square root of a squared? A, and that's how many units it will be stretched in the x direction. We look at the number under y squared. It's b squared. We take the square root of it. What's the square root of b squared? B. And that will be the number of units that it's stretched in the y direction. For ellipses, we always say this, that A is greater than B. The notes are way more confusing than the actual graphs. Okay, there's another equation. If you want to stretch it vertically, just say x squared over b squared plus y squared over a squared is equal to 1. So we always say that a is the greater stretch. So you can see here this one is stretched vertically, so we're going to say that it's a units vertically and b units horizontally. You okay with that? Yeah. Anna, could you always wear glasses? Just today? Forgot contacts? I wear contacts too. And when I get home at night, I take them off, put my glasses. Sometimes I wear glasses to school, and then people point at me and laugh. I will never point and laugh at you. I think you look very intelligent today. Not that you look dumb on other days. Okay, vertices. We say that the vertices are the endpoints of where it's stretched. So what are the endpoints of where it's stretched? negative a0 and positive a0, right? So you could just write it plus or minus a0. And if it's stretched vertically, still, what are the endpoints? Yes, only it's 0 and plus or minus a. Because we don't refer to as b as vertices. They're just extra points. I don't know why. I would have included them. I don't like things being left out. The major axis is the distance between the two vertices. How far is it? 2a, thank you. In both situations, it's 2a. The minor axis will hopefully satisfy Hannah's question earlier. That's the distance between the other two, which is 2b or not 2b. That is the question. Foci. Foci sit in the middle. So foci here, F. Foci here, F. All right? And they sit C units from the center. Sure. No, I F1, F2. It doesn't matter. You call it whatever you want. Call it Mason for all I care. I don't. The whole point is this is sure. The whole point is that we want to just name the coordinates of the foci. For the horizontal one, what are the coordinates of the foci if it's C units from the center? Plus or minus C, 0. Very good. And what are the coordinates for the vertical one? 0 plus or minus C. So the reason why ellipses were so interesting, and they've been around for thousands of years, because in early times, people wanted to be able to map the orbit of planets. And our planet does not travel in a circle. It travels in an ellipse. And the measure of how wide or how far an ellipse is stretched is called its eccentricity. And we calculate eccentricity by taking the C value and dividing it by the A value. And the closer the eccentricity is to 1, the more stretched it is. The closer the eccentricity is to 0, the more it looks like a circle. So it doesn't really matter. It's just something we do, okay? There you go. So it's fun. It's a word. Your parents will ask you what you're doing. You're like, oh, I'm calculating the eccentricity of conic sections, particularly the ellipse. They'll be like, okay, wow, you're really smart. Just take C divided by A. It's no big deal. Okay, so we want to sketch a graph, so we're going to do that. I'm going to get out my handy-dandy straight lines. And for all this stuff, what I do is I identify the center. I identify the vertices. I identify the length of the major axis, length of the minor axis, the foci, and then the eccentricity. Center. Yep, the center's going to be, what do you think center is? 0, 0. Because the reason why I put that here is because we're going to shift these things later on. So the center won't be 0, 0, and everything else will change. What? Major. If you look up above, okay. So, now, I don't worry about what A, B, and C are right now. I guess you can. A is always the bigger value, so is A squared going to be 25 or 4? Okay. I don't really try to think about that. I just look at this. The bigger number is under y squared, correct? And this tells me how many units it's stretched in the y direction. I simply take the square root of the bottom. What's square root of 25? So it's stretched 5 units vertically. So I just go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And those are the endpoints, or the vertices, of the ellipse. How far do you think it's stretched horizontally? 2 units need stretches. That's how easy these things are to sketch. That's all you have to look at. And right now, as a matter of fact, you can sketch the ellipse. Now, don't make fun of mine. People did third hour. I'm not very good at these, and you probably aren't either. That's probably my best one of the day. there's kind of different groups. There's people who draw more kind of pyramids, or I'm sorry, like kites. Then there's other people who draw more egg-shaped ones, and then other people who draw perfect ones. Look at your partners. Who's got a perfect one? Ooh, there we go. Fran's got kind of the diamond thing going a little bit. Okay. Yep, there we go. Sam's classic here. He's got an egg-shaped one going. Okay, it's heavier towards the bottom. You know, kind of pear thing. Ooh, haven't seen this one before, especially from a baseball person. He's got the track going. This is like a, he's got the track thing going. Yep, that's kind of cool. And I don't know if I see a perfect one. Let's see, Annika. Hold it up. Hold it up. It's the glasses. Whoa! Holy cow! Did you hear that? It's not even good. Wow. Okay, arm wrestle right now. Yeah. Yes. Yes. Yeah. Yeah. All right. Before we get into a fight, let's move on, okay? The vertices are going to be the endpoints of where it's stretched. So, going to be what? 0 plus or minus 5. Make sure you end up in the right spot, X or Y, okay? The length of the major axis, 10. Length of the minor axis, 4. Major axis, top to bottom. Minor axis, across. Okay? Because it's stretched that direction. Foci, I have to be able to find C. Oh, I didn't tell you that. Here's how we find C. C squared is equal to A squared minus B squared. So it's like the Pythagorean theorem, except instead of a plus, it's a minus. So we do C squared is equal to, A squared is always the bigger one. So what is it? 25 minus B squared is always the smaller one. 4. So C squared is 21. So C is equal to about 4.5. Nope. We're looking for a distance. So we keep it positive. Foci. So I'm going to go 4.5 units. The foci always sit along the major axis. So they sit in the direction that's stretched. So I just go 4.5 up, 4.5 down. So you could write the foci as 0 and then plus or minus 4.5. Or you could write it as 0 plus or minus the root of 21. You know, however you want to write it is fine. I'll accept either or on the test. Then to calculate the eccentricity, I take the C value, which is 4.5, and I divide it by the A value, which is 5. 4.5 divided by 5 is about 0.9. So that's fairly close to 1. So we'd say that this is a fairly stretched ellipse. Okay? And that's it. It's not that bad, is it? Now that you've seen the whole thing go through once, watch how nicely this one works out. I mean, you're going to be able to fly through this. The only problem is that sometimes it's not in the form that we want. So it's got to be set equal to 1. So what are you going to do? How do you get it equal to 1? Divide by 36. 4 over 36 reduces to? Oh, ain't that nice. 9 over 36 reduces to? And 36 over 36 is 1. Now, is it in a form that we can work with? Yes. Isn't that nice? Okay, so is it stretched more in the x direction or the y direction? X direction. Get my handy dandy straight line maker. And I'm going to go, how many units in the x direction? 3. How many units in the y direction? So, here's your chance. Oh. Pretty tough. Yeah, an opposite world, that is perfect. Okay, let's see. Pretty good. I don't think it's as good as Anika's was before. Center, vertex, major axis, minor axis, foci, eccentricity. You tell me, what's the center of this beast? 0, 0. Vertex, vertices. Very good. Plus or minus 3, 0. Those are those blue spots. The major axis is the green one, the distance all the way across, which is 6. The minor axis is the other distance, which is 4. See, a lot of people try to figure out the description first, then graph it. I don't like that. I like to do the graph, then the description. It's easier. Okay? Foci, I got to find what value? C. So I go a squared minus b squared. What's a squared? 9 minus 4 is 5. So square root of 5 is like 2.21. 2.24? Oh. 2.24. So which direction, x or y? X. So plus or minus 2.24. If you want to write it as square root of 5, that's fine. So those are my foci. So, you know, you should plot the foci. You don't actually need them to draw it or to sketch it by hand. But if we were to actually do it on the board, we would create 2 foci and do it. So, and then eccentricity, we take 2.24 divided by 3, and I get like 0.74, something like that, 0.75. So this is not as stretched as the previous one. It's just a measure of how stretched it is. That's it. What do you think? Well, flip it over. I'm going to go through this really quick. I'm going to take the last one we had, and let's say you want to know if you sketched it correctly. What I'll do really quick here is I'm going to graph this on my calculator. When you go to graph something on your calculator, you have to enter for y equals, correct? So I would need to solve for y. 9y squared equals 36 minus 4x squared. Yep, if I want to solve for y, what should I do? Divide by 9. I get 4 minus 4/9 x squared. Now what do? Take square root. And if you take the square root of an expression, take square of a number, we're asking for the positive value. But if you're taking the square root of an expression, you need to list positive and negative. So we got plus or minus the square root of 4 minus 4 over 9 x squared. No, you can't take the square root of 4 and 9 because you got the subtraction sign in the middle. It doesn't work like that. So I go to my handy dandy calculator, I turn it on, and I go into y equals, and I type in the square root of 4 minus, parentheses, 4 divided by 9, x squared, parentheses. Now you tell me, is an ellipse a function? No, your calculator can't graph a function. Well, look what I'm graphing. I'm graphing that. And if I zoom as a decimal, did it graph the whole thing? No, it just graphed the top. Whereas if I now place in the negative second square root of, same thing, 4 minus 4 divided by 9, parentheses, x squared, parentheses. Now, it completes it on the bottom. So you need to be able to do both of them if you want to graph it as a function. There are other ways that your calculator can graph things that are not functions, but it's a little bit more difficult. No. like I just did that one, but you don't know how to work in polar or parametric forming. So let's do our last two examples. Now that you know how to graph it, you know how to check your graph, let's learn how to write equations for these things. It says the focus is 0 plus or minus 4, and the vertices are plus or minus 5. So A for the day, is this graph stretched horizontally or vertically? It is vertical. A few people have said it, because the vertices are located on the y-axis as it's being stretched that way. Whereas the focal points are also in that direction. So we know it's vertical. We don't know how wide horizontally this thing is stretched out. But what we could do is we could say x squared over something plus y squared over something is equal to 1. We know that that's the general form for an ellipse that's centered at 0, 0. Now, how many units is it stretched in the y direction? 5. So therefore, what number goes under y squared? 25. If the foci are 4 units in each direction, then what is c squared? 16. So we know that c squared is equal to a squared minus b squared. C squared is 16. If this is 25, is that referring to a squared or b squared? A squared. Why? Yep, because the vertices, this can be the larger. So 25 minus b squared, how do you solve? Negative 9 equals negative b squared. So 9 is equal to b squared. So 9 goes underneath. So that's my equation. What do you think of that? You don't have to draw it, just as write an equation. I sketched it so I could understand better that this was going vertical. So I just sketched those points so that I would have the benefit of, I was less likely to make a mistake. All right, the next one, last example, endpoints of square plus or minus 2 roots of 2 and 0 on the minor axis and a distance of 10 between the foci. So endpoints of plus or minus 2 roots of 2, 0. Is that the minor axis or the major axis? Minor. Is that on the x-axis or the y-axis? X-axis. So if the minor axis is along the x-axis, is this going to be stretched x or y? It's going to be stretched y. Okay. We'll plot these so we can get an idea. I know that the square root of 2 is 1.41, so 2 roots of 2 will be 2.82. So I'll go 3 units in each direction. So the endpoints are right here. But the foci, do the foci lie on the minor axis? No. So the foci are going to be 5 units up and 5 units down. How did I know that? Because it's 10 between them. So it's going to be 5 units in each direction. So I have x squared over something plus y squared over something is equal to 1. Do I know if this thing is stretched in the x direction? Or I'm sorry. Do I know how far it's stretched in the x direction or how far it's stretched in the y direction? I know how far it's stretched in the x direction. The x direction stretched 2 roots of 2. So that means that the number that goes underneath here is 2 roots of 2 squared. Correct? What do you get if you take 2 roots of 2 squared? 4 times 2 is 8. So 8 goes underneath it. We don't know how far it's stretched in the y direction. Okay, but we can figure that out. We can start to use our pieces using this equation. C squared is a squared minus b squared. Do you know c squared? which said 8, 10, and 100. None of them are right. 25. Why? Yep, C is the distance that your foci are from the center, 5 units, and you square that to get 25. A squared, do we know A squared? No, A squared is going to be the distance that it stretched vertically. Do we know B squared? Yep, minus 8. How do we solve? So 33 is A squared. So, yeah, life is nice when you got numbers like 9 and 25 or 36 and 49 or 81 and 1. But right now, you can see that neither one of these are perfect squares. And that's fine. You can still work with them. But that's your equation for the ellipse. What do you think? Easier than parabolas, aren't they? I know. You just want an assignment. You're bored. Got nothing to work on. Here's the deal. You got this stuff. 1 through 4 are just matching, okay? 5 through 10, like we did, they're graphing. And then those odd ones are writing the equation. Yeah, when I looked at it again, I was like, it looks like HO, but it's 1 through 10.